Hi everyone, welcome back to our channel. Today, we're diving into an advanced Swift programming topic, the copy-on-write technique. So, let's get started. In Swift, this technique is particularly useful when working with value types like arrays, dictionaries, and strings. But what does it mean? And why should you care? Value types are types that are copied when assigned to a new variable or passed to a function. This includes structs, enums, and collections like arrays and dictionaries. The idea behind copy-on-write is to delay the actual copying of the data until it is modified, rather than when it is simply assigned or passed around. Let's break it down with an example. Imagine you have an array in Swift. When you assign this array to a new variable, Swift doesn't immediately create a new copy of the array. Instead, both variables point to the same underlying data. This is efficient because it saves memory and processing time. In this example, original array and new array both point to the same data. No copying has occurred yet. You can see that both variables have the same address. Now, here's where copy-on-write comes into play. If you modify the new array, Swift will then create a copy of the data to ensure that original array remains unchanged. When you append an element to new array, Swift detects that a modification is happening. At this point, it makes a copy of the original data, and new array now has its own separate copy. Original array remains unaffected. You can see that the addresses have now changed, indicating that new array is now a separate copy. So, when should you use copy-on-write? It's typically used in the implementation of Swift's standard library collections. If you're creating your own custom value types that hold onto resources or large amounts of data, you might consider implementing copy-on-write to optimize performance. But how to do this? Let's look at how you can implement this technique in your own custom types. We have a ref class that holds the actual data and a box struct that uses a reference to this class. The box struct ensures that a copy is only made when the data is modified, and the reference is not unique, thus implementing the copy-on-write technique. Now, let's test this custom implementation to see how it works in practice. In this test, we create a box instance box1 with an initial value of 42 and print its address. We then assign box1 to box2 and print the address again. At this point, both box1 and box2 reference the same underlying data. However, when we modify the value of box2, a copy is made. The addresses are now different, indicating that box2 has its own separate copy of the data. The values of box1 and box2 are now different as well. Thanks for watching. If you found this video helpful, don't forget to like and subscribe for more programming tips and tutorials. And if you have any questions or topics you'd like us to cover, leave a comment below. Happy coding!